This lesson is about the use of excess and limiting reactants in chemical reactions. The first thing we want to do is define what a limiting reactant and excess reactant are. This situation can be described as having too much of one reactant and not enough of the other. It can be exemplified by this situation where we want to bake cookies and we line up our ingredients. Now, when we line up our ingredients, we can see that we have plenty of flour, eggs, and butter, but we don't have enough sugar. And if we measure our quantities, we may discover that each quantity of the ingredient will allow us to bake a different number of cookies. So the question is, how many cookies can we bake and how much of the other ingredients will we have left over? Now, the sugar in this example will be our limiting reactant because it's limiting our abilities to bake cookies. So the number of cookies that we can actually produce is the one that is given by the limiting reactant. So we can define as limiting reactant the one that is used up first, or the one that is completely consumed by the reaction. And we call excess reactant the one that is present, or the ones that are present in greater quantities than actually needed. So let's look at an example in chemistry. For our reaction of carbon monoxide with hydrogen gas, suppose we have 5 moles of carbon monoxide and 8 moles of hydrogen gas. How many moles of methanol can we produce? Now, when we look at the numbers that we're dealing with, we can see that unlike when we were working with exact quantities, we have quantities that are not exact. So what we need to determine is which one is the limiting reactant. And once we determine which one is the limiting reactant, we can use that ingredient or chemical to determine how much product we can produce. To determine which one is the limiting reactant, we need to determine how many moles of each of the compounds we need for this reaction. If we have 5 moles of carbon monoxide and 8 moles of hydrogen gas, we can determine how many moles of the other reactants are needed to react with the reagent we have. So say, for example, we look at the 5 moles of carbon monoxide. If we transform those into moles of hydrogen using our conversion factor, we can see that 10 moles of hydrogen gas are needed for this reaction. By comparing the number of moles that are needed for the reaction with 5 mole of carbon monoxide, we can see that we do not have enough moles of hydrogen gas for this reaction, which means that our hydrogen is the limiting reactant for this reaction. So once we determine that, we can establish that for the reaction of 8 moles of hydrogen gas, we need 4 moles of carbon monoxide. This tells us that we have more than plenty moles of carbon monoxide to react. So carbon monoxide is the excess reactant. We can now determine how much product we can obtain through this reaction. In order to do that, we're going to use the limiting reactant moles. So 8 moles of hydrogen gas can be converted into the moles of methanol, which is CH3OH, and we can see that we can obtain 4 moles of methanol. How much of the excess reactant is left? This can simply be calculated by the amount that we have minus the amount that we used. So we will be left with 1 mole of carbon monoxide. Let us look at an example on the notepad on how to approach this. So we have our reaction here, and this is 3-NABr plus phosphoric acid gives us sodium phosphate and hydrobromic acid. If we have 0.327 moles of NABr, and we looked at this example when working with exact quantities, we can determine how many moles of H3PO4 we will need for this reaction. So we can write our 0.327 mole of NABr, And then we convert this into moles of H3PO4 by using our conversion factor, which is 3 mole of NABR per 1 mole of H3PO4. And this will give us 0.109 mole of H3PO4 needed. If we have available 0.2 moles of H3PO4, that means that we have plenty, actually more than we need, of the phosphoric acid. That makes our NABR our limiting reactant and our phosphoric acid our excess reactant. At this point, the quantity of product that we can have in terms of sodium phosphate and hydrobromic acid can be calculated from the limiting reactant. The amount left over of phosphoric acid will be the 0.200 mole that we have available minus the 0.109 mole that we will use for this reaction, and this will give us the leftover of the product. Now, likewise, in the chemical reactions that we see with exact quantities, when we work with the limiting reactant, we normally work with masses rather than moles. So how do we approach this problem? So we are preparing magnesium oxide, and we have 5 grams of both magnesium and oxygen. So what will be the amount of magnesium oxide that we can produce? In order to determine that, we need to first establish which one is the limiting reactant, because that is the one that will determine how much product we can form. So I'm going to pass again onto my notepad where I wrote my reaction and I have my quantities. So in order to determine the quantity of magnesium oxide, first of all, I want to determine the amount of which one is the limiting reactant. To do that, I need to establish the ratio of moles. So first of all, I need to convert my 5 grams of magnesium into moles. The molar mass of magnesium is 24.3 gram per 1 mole. And then I can convert these into the moles of oxygen. And my ratio is, so this will be moles of magnesium, so 2 mole of magnesium per 1 mole of oxygen. And as a result, I'm getting that I will need 0.103 mole of oxygen. Now, if I need to compare these and see if I have enough moles of oxygen, I need to first determine how many moles of oxygen I have. So 5.00 gram of oxygen will give me, divided by 32.00 gram per 1 mole of oxygen, is going to give me 0.156 mole of oxygen. So by comparing these two quantities, I can see that my amount of oxygen available is higher than the amount needed, which means that the oxygen is the excess reactant and the magnesium is the limiting reactant. So once I know this, I can actually calculate using, so this will be my limiting, I can actually calculate the amount of magnesium oxide I can produce by using the limiting reactant. So I'm simply taking my 5 grams of magnesium, and I will convert that into magnesium oxide. So for 1 mole of magnesium, 24.3 grams per, and we have 2 mole of magnesium per 2 mole of magnesium oxide, and this will give us, multiplied by the molar mass of magnesium oxide, which is 40.03, So solving this string, I'm going to get that the amount of magnesium oxide I can produce is 8.30 grams. So 8.30 grams is the amount of magnesium oxide I can produce, and it's calculated from the limiting reactant. The amount of oxygen left over can be calculated simply the difference between what I have. So I have 0.156 moles of O2, subtract the 0.103 moles of O2, and that can be converted into a mass by simply multiplying by the 32, which is the molar mass of oxygen. And that will give me the amount of oxygen I have left over in grams.